Hi, it's me, Angelica again, and I have created a simple lexical scanner that analyzes Java variable declarations and identifies their tokens. A lexical scanner, also known as Lexer, and it is the first phase of a compiler that reads source code and breaks it down into meaningful units called tokens. So, this is the package, simple lexical scanner, and I import array list. So we know that array list is far different to normal creation of array because this array list is um, helps us to be our array elements becomes resizable. So um, could be the size of an array list can grow or shrink dynamically as we add or remove elements. And scanner, obviously, we input scanner because we take input in our console program. And we also import regex matcher or the regular expression. So this is used to perform operations on text and it used along with the pattern class. That's why we also import the regular expression pattern. Um, this pattern class represents a compiled regular expression and it defines the rules for matching text. Like, for example, we'll find numbers, words, or specific patterns in string. So let me show you my Java program I've created. Here a class called Simple Lexical Scanner with several key methods. Our main, where it takes user input and displays the tokenized output. Then we have tokenized. So this is the processes input string and identifies each component. Then we also have identity identify token. So this is to determines what type of token each lexeme is. And we have several methods, helper methods to check for different token types. So the program can recognize various token types, including data types such as int, global, float, string, and others, and also on identifiers like the variable names and assignment operators, numeric values, semicolons, and others. So um, so that we can visualize the code, we will run first the program with an example. So let's run this one. Okay. So simple lexical scanner, enter a Java variable declaration. For example, our input is int var one. So obviously, as we can see, we input a data type, we input an identifier, an assigned operator, a value, and a semicolon. So let's try if our program can identify our input. Okay, so the output is data type. That is correct because int is identified as a data type. Then ID, which identified as the var here, identified as an identifier as our variable name. Then the equal sign, which is our assign operator, assignment operator. Then one, which is our value, and semicolon, identified as semicolon. So next, for example, on the previous example we use integer. Now let's try to have double. Double price equals 99 99.99. Okay. So analyzing input, our output, we have data type, our double, then price is our identifier, equals is our assigned operator, then 99.9 is our value, and semicolon. So perfect. It correctly identifies double as data type and 99.99 as our numeric value. So how about if we will input string? So we have string name equals Yuki. Okay. So the the output we have data type for our string, then name for our identifier, then equals for our assign operator, and Yuki. So this is string literal and the semicolon. So excellent. Our scanner recognize string as our data type and identifies that the coded text as a string literal. So on our previous output a while ago, we just have value. But if we will use string inside the double quote, it identifies as a string literal. So now, let me explain the source code in detail. So first, we have it here. Okay. So it's a straightforward. We create a scanner object to read the user input and get the input string called our tokenized here as our method and display the result. So here is what we see in our um, output a while ago. So simple lexical scanner, enter Java variable declaration, then input, then scanner that next line to take the input of the user or as what we input. Then analyzing input, just a display text. So then this is the method we get, and then we call out the output inside our tokens. This is from our method tokenized here, and then scanner close. So um just a basic straightforward code we used to have. Next, we'll talk here. The method tokenized is where the main processing happens. So this is the code that really matters in our problem. So we use string builder because um, this is efficient for string concatenation. A string builder result equals the new string builder. And then array list, string lexemes equals the new array list, the resizable array. Then we used input equals input the trim to removed spaces. Then this is also split that the input by white space. So we have it. And then for each part, we check if it ends with semicolon. So here, int I equals 0, while I is less than input dot length, char c, input dot char at its for the character. So if the character is white space, I plus plus, then we continue. This is to skip the white space, and this is to check for semicolon here if C is equal to semicolon. So C, this is our input character here. our variable C. Then we will add semicolons. So this is to check for assignment operator. Check for string literal starts with the double quote, like the string. Example output a while ago, the string. So while that's also here, string append C plus plus C and then the I plus plus. Then this is to read here we read the closing quote, and here is to add a closing quote, and here is to read the identifier keyword or a number. And now we identify each lexeme. Okay, so we just identify the token for that part, for these parts, and finally we return the token. We return the complete token string. And in our next method, the identify token determines what type of lexeme is. So this is to check for semicolon, to check for assignment operator, then to check for data types, check for operators. This will check for Boolean value, just true or false. Then check for string literal, and to check for numeric value, and check for the identifier and the unknown token. So if none, then it will return unknown. Um, Order matters because we check data types before identifiers, because int should be recognized as a data type, not an identifier. So now here the helper methods to do the actual validation is data type. This is to compares against known Java data types. So return lexeme that equals int, or it returns if the lexeme is equals to double, or a float, a char, a boolean, string, long, short, or byte. So if the lexeme will identify that your data type is in a float, then it will display float, and so on and so forth. And next is separator. Same way around, to identify plus as an operator, minus as an operator, asterisk for multiplication, still an operator, division, modulus, equal. These are all entered into operator. And we have is numeric. So is numeric, it uses a try catch to check if it can be parsed as a number, double, then the number format exception. And what else? We have is string literal, like we use the double quote. What else? Is identifier. It uses a regular expression to validate identifier rules. Here we have pattern. Pattern equals a new pattern, A to Z, and the special characters. So this expression means start with a letter or underscore, followed by any combination of letters, digits, or underscores. So we already saw the output, and we have a follow-up questions in our activity to um sum up our code. It implements a simple lexical scanner, and we follow five principles. First is the modular design, which I separated concerns into different methods. The main for the input and output, then the tokenized for processing, identify tokens for here, identify tokens for classifications, and helper methods for validations. Then the pattern recognition, the scanner uses string comparison, regular expression, and exemption handling. This is to identify different token types. Then we also have another principle of sequential processing, which it processes the input left to right, identifying each lexeme and classifying it into its appropriate token category. Then extensibility, where the design makes it easy to add new token types by simply adding new helper methods and conditions here because we separate each of them. And then error handling. We have unknown tokens are labeled as where is it? Known rather than causing the program to crash. So we have a return here. Then this demonstrates that the fundamental concept of lexical analysis, converting raw text into a structured tokens that can be used by a parser in the next phase of compilation. So to summarize, I've created a functional lexical scanner that accepts data variable declaration as input, identifies and categorizes lexemes into tokens, handles various data types and values, and demonstrates the core concept of lexical analysis in a compiler design. And this is a simplified version of what real compilers do in the first phase of processing source code. So again, let's have it here, our output we just have here and mm, number equals 3. So see, we have an output int data type, the ID, the assign operator, the value, and the semicolon. So what else? Let's have some review of our code. Um, Always remember here the part of this. The purpose is this is our method header. This takes a string parameter and returns a string of tokens, which is static, can be called without creating object. Then this string builder result equals to new string builder. The purpose of this is to efficiently build our result string, and string builder is better than string for concatenation in loops. Then here array list string lexemes equals the new array list. We create an array list to store all the individual lexemes or pieces we find in the input. Then here again, um, removed any leading or trailing white spaces from the input string. Then what else? Int I equals 0. Yeah. Int I equals 0. The purpose of this is to create an index variable I to track our current position in the input string, which will start at position 0 first character so that it will read left to right. Then if while I is less than input dot length, this is purpose of this is to loop through each character in the input string and continue while I is less than to the total length. For example, we put num. So and the input length is 3. So our I is 0. So it will loop. Then if our I becomes 3 because it starts with 0, 0, 1, and 2. So it will stop should be at that 2. So if our I becomes 3, then it will end the loop. So char C equals input char at I. This is to get the character at position I and store it in a variable C here. Then, if character is white space, this is to check if the current character is a space, tab, or a new line. And I++ continue, this is if it's white space, move to the next character, the I++, and skip the rest of this loop iteration. Then, same with the I. As same with a C is equal to a semicolon. This is to check if the current character is a semicolon. And if yes, this the add. If yes, then lexemes here. If yes, so it will add a semicolon as a separate token to our list. And the I plus plus continue is to move to next character and continue the loop. Remember, we follow left to right. And then C is equal to equal. So this is to check if the current character is an equal sign, assignment operator. So here, lexemes that add. So if yes, it will add to our lexemes list. And same, I plus plus continue is this to move to next character and continue. Then if C is equal to double quote, same process. To check if the current character is double quote, start with a string literal. And here, string builder str, we create an object. So this is to create a string builder to build the string literal and add the opening quote. And I plus plus, this is to move to the next character after the opening code. And we have here a condition while I is less than the input length and input to the car at I not equals to double quote. So the purpose of this is to keep looping until we find the closing quote or reach the end of input. And this string append is, and the I plus plus is to add each character to our string and move forward. So this line of code, if we found a closing code and need to complete the string literal and move past it, then the lexemes add string str as our object name, then to string and continue. This is to add the complete string literal. Example, we have the name we input a while ago, Yuki. So to our list and it will continue. And the string builder token, new string builder, we create a string builder to collect a characters for identifier, keyword, or a number. And this condition is to keep reading characters as long as we haven't reached the end where I is less than input dot length and the current character is not a white space and the current character is not equals semicolon or a double quote. Then the token append and the I plus plus is to add the current character, the token and move forward. Then if token dot length, like me, this line of code, we collected any characters and add a complete token to our list. Then for string lexemes, this is the loop through each lexeme we collected in our array list. And if not lexeme is empty, so we make sure that lexeme is not empty, then the result that append this is the and then we call the method classify the lexeme and add the result to our result string and followed by space. And result that to string, then trim. This is to convert string builder to string and remove the trailing space with trim and return the final result. And in our identify token line, the purpose of this is this method that takes a lexeme like int or var and returns its token type like data type or the identifier. So if lexeme that equals the semicolon, so we will return the token to semicolon and all here. And with our um other other um other checking part. And to our another helpers, our helpers is just for validation. So, what else? I think that's all. So, we use the string builder so that it could be efficient string building in loops. We used a release to dynamic list that can grow. and the character by character parsing, which could leads to flexible tokenization, the helper methods, modular reusable code, the regular expressions, pattern matching for identifiers, and the try catch for our error handling for your number parsing. That could be all. Thank you for watching.